This is the final project for Big Data System in Practice. Here is my presentation. We use the KDD CAP99 dataset in this project. This dataset is used for the third International Knowledge Discovery and Data Mining Tool competition. And in this dataset, a lot of network connections are included. For example, some connections are good connection, which is just the normal traffic over the internet, but some of them are kind of attack connection, which is performed by some hack event in order to break the server or even steal some information from the network server. So it's very necessary for us to train and classifier in order to predict whether a connection is good or harmful. There's a significant problem in this dataset. The most important one is redundant records. As you can see on this table, the original records have about 3 million records in attack, but the distinctive records in them are just 200,000. At the same time, the normal connection is about 900,000 in original records, but only 212 are distinct. The same thing happens on the test set. What will happen if we have this kind of redundant records in the dataset? If when we use some kind of instance-based learning, the number of instances or the number of these redundant records may have some very bad impact on the result because it will make the classifier more biased to some specific inputs. So we need to reduce these records. We found a solution given by the CS department of UMB, and we downloaded their corrected dataset, which just remove all redundant records from the training and testing set and we perform our test and training process on this new dataset in this assignment. For the data preparation, description about the dataset that there are 24 different types of attacks, but they can be classified into 5 catalogs, including normal, DOS, CNR, and other kind of things. So I manually changed all tags to this 5 catalog representation, which can simplify the model. Otherwise, we may need to use some unsupervised clustering algorithm in order to predict whether a specific attack type belongs to some catalog. About the platform, many different platforms and tools are used in this project because some tools cannot be used by some algorithm. For example, the MapReduce in Hadoop cannot support some algorithm which requires a lot of integration and which cannot be paralleled. So I also use R Hadoop and Python. Also, I use RWeka package in R in order to deal with the data and do some very simple tests. So here is my experiment result. I performed 4 different algorithms on the whole dataset, including naive Bayes, Bayes-Bliss network, decision tree using J48, and locally weighted learning, which is a special case, which is an implemented or kind of improvement of the KNN algorithm. And here's the performance. The famous naive Bayes got about 72% of accuracy, and he misclassified about 6,000 instances. It works fine, and for the next one, the Bayes network, it classified 73% correctly and about 6,000 wrong instances, which is very similar to the naive Bayes. However, it's a little better than the naive Bayes because I think it's major because the Bayes network has a much looser assumption than the naive Bayes classifier. And the decision tree is kind of key in this classification because it works well that it performs a 77 percentage accuracy, and it only misclassified 5,000 instances. And the last one, the lazy learner KNN algorithm, it works just like the naive Bayes, and it misclassified about 6,000 instances. And as a result, the decision tree is the best algorithm in this task. So we may find that once some instances of a dataset are represented by a set of attributes which can be represented by a list of rules, or in other words, which can be separated successfully by some kind of rules, then we can use decision tree. And in another situation is that when the dataset includes a lot of noises, the decision tree is also the first choice. Thank you.